Hey everybody, we are going to look at a free body diagram problem involving elevators today. So our given problem is that an elevator with a mass of 64 kilograms is going up and speeding up with an acceleration of 4.52 meters per second squared. How much tension is on the cable? So with any free body diagram problem, we start with a free body diagram. So I'm going to draw one real quick, and keeping it nice and simple, I'll just use a box. And there's only two forces that we have to worry about in these problems, and that is gravitational force on the elevator and the tension force on the elevator. And both are along the vertical axis. So I'll draw one vector here for gravitational force, and then I'll draw another vector here for tension force. And I'm denoting those with a uppercase F and then a subscript, so F sub T for tension, F sub G for gravitational force. And now we're told that it is going up and speeding up. And so that's going to help us to figure out which direction is this thing accelerating. So if it's moving upwards and it's increasing its speed, it must be accelerating in the upward direction as well. If it were moving up and slowing down, then that would tell us that it's accelerating in the direction opposite of motion, which would be down. So in this case, acceleration is equal to 4.52 meters per second squared, and it is accelerating at that rate in the upward direction. Now, this isn't always going to be the case. Sometimes acceleration will be downwards, and that means that down will be positive. And that's okay. If you're setting up the reference frame, you can make negative and positive any direction you want. It doesn't always have to be down as negative. And that's going to be really handy later on with more complex problems that you might see in other physics classes, where you do need to change the direction of things. If you use acceleration as kind of the foundation, knowing that whichever way this thing accelerates, all of the individual forces need to sum to a net force that agrees with that, then you can do a whole lot of different types of problems. So in this case, acceleration is up, so we'll say positive is up. We are also given a mass of the elevator, but we want the force of gravity, or the weight of the elevator, and we can use this mass to calculate that. So using a variation of Newton's second law, which is, we know F equals ma. Well, force of gravity is equal to the mass of the object times gravitational acceleration, which is 9.8 meters per second squared. So Fg is going to be equal to the mass of the elevator, 64, times 9.8. And when I run that through a calculator, I'm going to get 627.2 newtons. So now I know both the mass and the weight of the elevator, which I'm going to need both of when I set up my equation. So now we have all our basic information. We're ready to do some math. We need to set up our equation. So we start with the equation without any substitution first. And so we basically are going back to Newton's second law. The sum of all forces, or the net force, is equal to the object's mass multiplied by its acceleration. So the sum of forces we denote with a sigma F, and then we also want to denote the axis that we're working with, because remember, horizontal and vertical are independent. So since we only have vertical, we're going to start right with that. So F sub y. So the sum of forces along the y-axis, that's going to be equal to those individual forces. So we have tension force plus, and now don't forget, we established that upwards is positive, so downward is negative. Since gravity is acting downwards, we put negative F sub g. And again, from Newton's law, a second law, we know that the sum of forces is equal to the mass of the object multiplied by its acceleration. All right, so now we start substituting values in. Sigma F sub y equals, well, we don't know tension. That's what we're solving for, so we'll leave that as F sub t. Plus, well, we already solved for the force of gravity, so we are going to put that in, negative 627.2. And we left it as positive up here. We found the magnitude, but we did not include any directional components because, again, this isn't always going to be negative. Sometimes this will be positive too if it's accelerating down. So we'll worry about the directional components in the equation. Up here we can leave it as magnitude. So that's why we left this. We didn't do negative 9.8, we just did 9.8. And so here we apply that negative in the equation. All right, so I have the two forces, and that is equal to the mass of the elevator, which was given, so 64, times the acceleration of the elevator. Now this point right here is where I see a lot of errors. A lot of students want to plug in 9.8 because they see acceleration. They think, oh, 9.8, cool. No, the acceleration that you put there is the given acceleration, A. Newton's second law says that net force is equal to the mass times the acceleration that net force causes. The sum of these two forces causes the acceleration of the elevator. 9.8 is used when calculating gravitational force because gravitational force is what causes an acceleration of 9.8 meters per second squared. Pretty much the only time you're going to use 9.8 meters per second squared in these problems is when you're calculating force or mass of the object. So in this case, the elevator has an acceleration of 4.52 meters per second squared. And now it just becomes an algebra problem. And so when you run it through a calculator and solve for that unknown tension force, we get that tension force is 916 newtons. Now you can do a quick check. Knowing that this is accelerating upwards, that means that the net force would also be in the upward direction as well, which means you should have more force going up than you do down. So we know that force in the downward direction is 627.2 newtons. This is a bigger number. This is upwards, and we should see a bigger number upwards. So that's a real quick check just to make sure something didn't go wrong in the algebra. And you could even take it a step further. You could plug this back in to Newton's second law, get the sum of forces, so tension plus gravitation, along with the mass of the elevator, and see if it works out to be this particular acceleration. All right, let's try another one. So we have an elevator with a weight of 706 newtons going down and speeding up with an acceleration of 6.07 meters per second squared. How much tension is on its cable? So again, we start with a free body diagram. And again, there are just two forces. We have tension force in the upward direction. We have gravitational force in the downward direction. So we'll denote those with an FG, F sub G, and F sub T. We are told that it has a weight of 706 newtons, and weight is just the force of gravity on a mass. So force of gravity is 706 newtons. And we're told that it is going down and speeding up. So if it is speeding up, then that means it must be accelerating in the same direction that it is moving. So in this case, we have an acceleration of 6.07 meters per second squared, and that is in the downward direction. So down is now positive in this problem. Down is positive, which might be a little bit of a mental shift for some of you, but yeah, down is positive. Now we know from the previous example we needed both mass and weight, so we might as well go ahead and figure out what the mass is of this. So if we know that F sub G is equal to mass times gravitational acceleration, again, this is just a variation of Newton's second law. So force of gravity is equal to mass times gravitational acceleration. Well, I know gravitational force. I don't know the mass, but I do know that G is 9.8. And so when I solve for that mass, I get a mass of 72 kilograms. So now I know both weight and mass. Now I can go ahead and start my math. So again, I start with the equation, and that is going to be the sum of forces in the y direction, and they are equal to, well, that's made up of the tension force plus the gravitational force. But don't forget, one of those is negative, and in this case, up is negative, so we need to throw a little negative there in front of the tension force. And again, that is equal to the mass of the elevator multiplied by its acceleration. So when we sub in the values that we know sigma F sub y is going to be equal to negative F sub t plus 706, because that's the force of gravity. And then that's going to be equal to the mass of the elevator, which we figured out was 72 kilograms, times the elevator's acceleration, not gravitational acceleration, the elevator's acceleration of 6.07. And again, this just becomes an algebra problem. So you'll end up finding that negative F sub t equals negative 269 newtons, but we want F sub t without that negative, so we'll just flip the signs, and our answer is going to be that tension force on the cable is 269 newtons. If you have any trouble with any of those, make sure you talk to your teacher. Thanks for watching. Have a good one.